Hello everyone, my name is Thi Luu. My advisor is Professor Yuan Chung. Today for joining in 2021 Khai Tinh Chitosan and Biomaterial Symposium, I would like to introduce my research with the title Enzymatically Triggered Graphene Oxide Release from Multifunctional Carriers Boost Anti-Pathogenic Properties for Promising Wound Healing Applications. As we know, wound healing is a great challenge due to virus hidden factors, especially pathogenic infection, and using a wound dressing is a necessary step for enhancing the wound healing process. Therefore, when designing a wound dressing, we want this product can provide a moist environment, have an antibacterial activity, promote cell proliferation, have good biocompatibility, can protect wound from the outside environment, etc. These properties will enhance and promote wound healing process. So, can hydrogels become the potential candidate for fabricating wound dressing? The answer is yes, because hydrogel have a good biocompatibility, non-toxicity, can absorb a large number of biological liquids, and have cost efficiency. However, the drawback of hydrogel are poor mechanical stability and low bacterial barrier. So in my study, to show the weakness of hydrogel, I used cross-linker isotretinoin to enhance the mechanical strength, and also using a potential biomaterial is graphene oxide to boost the activity against bacteria and prevent the resistant bacteria of using antibiotics. Here is the method that I done for hydrogel fabrication. First, to illustrate the effect of cross-linking degree on gel properties and graphene oxide release, I use different concentration of xanthine, and this is the abbreviation of sample name 2GPX and 3GPX, which is the concentration of xanthine. And secondly, to estimate the effect of graphene oxide concentration on gel properties, cytotoxicity, and antibacterial studies, I use different concentration of graphene oxide, and abbreviation is 3GOY, with Y is concentration of graphene oxide. After that, I evaluated characterization and property of material to optimize the good hydrogel formula. Finally, I perform activity study as antibacterial wound healing assay. So here is the result and discussion part of material characterization study. To know the rule of xanthine in cross-linking degree, I do cross-linking degree with different xanthine concentration and do storage modulus and loss modulus of 2GPX hydrogels. So we can see here the degree of cross-linking increased to the increase in xanthine concentration, and to evaluate the effect of graphene oxide, I do V-cos elasticity of 2GPX versus 3GPX and 3G, and fixing one level of cross-linking degree using 1% weight xanthine to a different concentration of graphene oxide, and the result show that the gel strength could be particularly improved by increasing the graphene oxide concentration in the hydrogel. And this is the result of enzymatic degradation and graphene oxide release with different level of xanthine in different collagenase concentration. We can see here plus line is 3GB3, which is the highest concentration of xanthine, has the highest weight remaining, and weight remaining is also higher in the low concentration of collagen, and the percentage of Graphene oxide release is depend on the genetic and collagen nature concentration. So these fabricated hydrogels were controlled release by cross-linking degrees and enzymatic levels. For the result of biocompatibility and wound healing assay, we can see human adipose-derived mesenchymal stem cell and human fibroblast cell culture in extract medium of hydrogel after 48 hours, so good cell viability about 90%, and the 3GL1 group significantly enhanced human fibroblast cell migration and after 12 hours of incubation and achieved complete graft closure by 24 hours. And this is the result of antibacterial activities. We can see here release of graphene oxide display uniform dispersity, retain its antibacterial activities against Staphylococcus aureus and B. aeruginosa. So in this study, I successfully developed a nanocomposite hydrogel system by graphene oxide impregnated into genetic cross-linked gelatin that has good mechanical properties and good activity as infection prevention, promoting human fibroblast migration. So this will become an excellent candidate for wound dressing. Thank you for your attention.